Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be talking about the book Clean Code, Chapter 5 by Robert C. Martin, of course. Chapter 5 on formatting. If you guys remember last time, we discussed Chapter 4, which was all about comments, and the biggest takeaway from this chapter was that comments should be used super sparingly. And there was a quote from this chapter that said, the best comment you leave is the one you don't actually write. Because in all reality, you shouldn't need comments if you name your variables properly and use descriptive names for your functions, descriptive names for your classes. Your code should end up speaking for itself to the point where you don't need a comment to explain the code. As long as you follow, the first 3 chapters and the naming conventions and the clean code principles that we've already gone through, you shouldn't need comments. Now, there are situations where comments are important. We talked about, maybe you want to display a trademark, maybe you want to mark the ending of a loop, although in very, very rare cases. But then again, like I said, sometimes they're needed. Most of the times they're not needed. Today, we're going to just continue along and talk about formatting. So formatting a file, spacing, indentation, how you structure a class or how you structure your source code file, etc. So let's kick things off with the purpose of formatting. So code formatting, Uncle Bob says, is all about communication. And communication is the professional developer's first order of business. If you guys remember from the introduction and the first couple chapters, when you apply clean code principles, it's communicating to your team. It better communicates to your team what your code is all about. If things aren't spaced, if things aren't named properly, you're going to have other team members who work in your repository wondering, what the hell is your code doing? But if you name things properly, if you follow the principles of these first 5 chapters, your code is going to tell a story. And that's ultimately kind of the way that we want to look at it. That's kind of the way that you want it to appear to a coworker. You don't want to have your coworker dive deeply for several minutes, hours, what have you, to understand what your code is doing. So you want to communicate in the best way possible. That's the first order of business. And formatting is something that is part of that communication. However, Uncle Bob says it's too important to ignore and too important to be treated religiously. So how I interpret this meaning is that what Uncle Bob means by this is, yes, it's important, but don't make it the hill that you die on. Meaning that, hey, if you spend too much meticulous detail on just the formatting and the spacing, okay, there's bigger fish to fry, so to speak. So I think that might be what he means here by that. It's too important to treat it religiously, like a religion, like you live and you die by it. And formatting is also important for another reason, because the style and the discipline of your source code files will live on. The indentation and the spacing and the vertical alignment, we're going to get into that in a couple slides. The vertical formatting and the horizontal formatting, those will live on even as your code changes and people make changes to your methods to add functionality to your classes. Your code is going to change. But if you guys have a plan of attack and some documentation surrounding formatting, that's going to survive on throughout the project. And it's ultimately going to lead again to this word communication for the length of your project term, but also for other developers that might come in and out of your team. Yes, the code might change, but everybody realizes that, okay, we do things a certain way here, and it's going to lead to probably better organization and communication just on your team on, best practices or just how we go about doing the work that we do. So, like I said, we're going to talk about vertical formatting. Vertical formatting, so if you think vertically, up and down, and how big should your source file be? Now, I can tell you at work, and here's what Uncle Bob says here, that there should be an upper limit of 500 lines for your source file. With most files are going to be about 200 lines long. And within these, between 200 and 500 lines, you're going to have a certain consistent number of things, certain consistent categories of things. And there's a newspaper metaphor to kind of illustrate this. In a newspaper, you have, like in an article, you have a headline, you have a synopsis, and then as you go down, the details increase, and then you have many, many different articles in that one newspaper. This makes it very usable. This makes it very organized, and just like Uncle Bob says here, do a little thought experiment. Think about if that newspaper was just one long run-on sentence and there wasn't, clever divisions between each article. It would be jumbled and confusing. But your code should kind of follow this newspaper metaphor. So you have the head of the file where you declare your class, you have your instance variables, you have your constructors, and then you have maybe your getters and setters, and that's where like maybe the details increase from there. You have other methods, such and such, and then you have other classes in that package or your directory that perform different functions. So that's how your source file should be, with an upper limit of 500 lines, with most of your, on average, I guess, most files are going to be around 200 lines. That means some are going to be way less, some are going to be a little bit more. But yeah, between 200 and 500 lines. So vertical openness between concepts. Sticking with this vertical alignment and vertical formatting, how you read the code is left to right. I don't know if it's read differently in other countries. No, I think it's left to right in other countries too. Well, it's like a book. You read it left to right. You read it top to bottom. And you read it like a book, like I said. And each group of lines should consist of a complete thought. So when you have spaces in between strings of code, blocks of code, it usually means a divergence in thoughts or functionality. So each group of lines is a complete thought, and then those thoughts are separated from other thoughts. So everything that's related goes together and then is separated by spaces. Separated by, you just hit enter, you can go to a new line. And Uncle Bob says you don't want to muddle things together when they are separate ideas or pieces of a picture. So in this class, in this screenshot to the right, you have a person class. All the instance variables are together at the top: private, name, age, date of birth. New line, you have your constructor. Everything's all in one line. Separated by then another line, you have your getters. You have your getters and setters, etc. So you can see how your instance variables, it makes sense. Keep them all together. Don't separate them. Your constructor, there's no spacing in between that. You just keep it all together. But your instance variables and your constructor are separate from each other because they're two different thoughts, two different pieces of the puzzle. And that's what Uncle Bob here is saying with this concept of vertical openness. Now, there's also another concept of vertical density. And if openness separates concepts, if openness is what separates those instance variables from your constructor, from your getters and setters, well, density implies close association. So it's the opposite. So concepts that are tightly related should probably appear together. And I don't really know actually if this calculator class that is on the right here, I mean, this is kind of a good example. I think a better example would be the previous class, because this way you can actually see how the instance variables are all close together. You know, you don't have this date of birth like with a couple spaces in between age and then date of birth is just hanging out on its own. That would be kind of confusing and just not very organized. So you keep it together with all the other instance variables. Your person multi-argument constructor here, all the this dot names where you're initializing the instance variables here, these are all close together. They're not separated by spaces because they're one cohesive unit. So there's openness between instance variables and constructor, but there's density among the instance variables and the constructor. I think the last screenshot probably gave a little bit better of an example of that. Well, to continue on this trend, we also have vertical distance. And this first bullet point kind of goes along with the vertical density that we talked about in the last slide. But concepts that are closely related should be kept close to one another. Very true. Closely related concepts should not be separated into other files unless you have a good reason. And even then, you really should probably reduce the need to hop around to other files trying to find things. So it kind of goes along with the density slide. Concepts that are closely related should be kept close to one another. So here, int sum equals 0. This is a separate thought. Then we have the for loop. Everything's together here. There's no spacing. Excuse me. So this is one concept that goes together. Then we have a separate average, which is separate from the for loop and from the sum, but it uses the sum. And then we have another line, and on a different line, we have the return. So again, if things make sense that they go together, you don't want to have much spacing in between them. But if they're separate things, if they're separate thoughts or pieces of the pie, put in an extra line there and separate them apart so that whoever's looking at the code can better tell the story of what your function or what your class is doing. Oh, sorry, one more bullet point here. Variable declarations should be as close to their usage as possible, and local variables at the top of each function. Okay, so that's kind of what this screenshot is representing here. Local variables at the top of each function. So we have this sum variable. It's initialized and declared at the very top of this function because we're going to use it later for this division and finding the average. And they should be as close to their usage as possible. So you see here, sum is close by here, it's usage here. So you don't have, sum declared up here, initialized up here, and then 50 lines, and then it's actually used like 50 lines later. You want it kind of close. So in this case, I think this is okay. You have it declared at the top, and then 1, 2, 3 lines down, you're doing some incrementing here by the number in this numbers array. So that's vertical distance. Instance variables, I had mentioned this earlier a little bit. Instance variables should be declared at the top of your class, as in if you're working in Java, which is what I use a lot at work. We also use React and JavaScript, but a lot of Java. And I didn't realize this, but in C++, apparently there's this scissors rule. Uncle Bob talks about this. And in the scissors rule in C++, your instance variables are actually declared at the bottom of your class, which I thought that was really interesting. So they're at the bottom. And then again, vertical distance should not be increased. They are used by many methods of the class. So basically meaning that you shouldn't have your instance variables at the top of the class and then them actually being used like way, way, way down, like 100 lines down. Now, normally in your class, like the person class, your instance variables are used right away. in your getters and setters and your default constructor, but you could just have a helper class and some private variables at the top. You want to have the functions that utilize those private variables should be close to them, basically. Shouldn't have an increased vertical distance between them. Next, we have these dependent functions that Uncle Bob talks about. So functions that are dependent on one another should be close together. So there's a rule that Uncle Bob says where the caller function should be above the callee function. So I have calculate sum, and then I have a calculate average function. You use the sum to calculate the average, right? So I would probably have the calculate average above the calculate sum function in a class, because the calculate average function is going to call calculate sum. So the caller goes above the callee. And again, if your functions call each other, they're one cohesive thought. You should try to keep them as vertically close together as possible, just to reduce coworkers or other people working in your code base from trying to find exactly where everything is, because you have a function at the top that calls a function 100 lines down, and they got to they got to scroll all the way down, work on it here, then scroll all the way back up. It can get, it just gets a little annoying. It's not that it's not like a huge time waste, but just could be better organized so you don't have to go through all that. And I think this is an example that I had of caller function above the callee. So here, topmost method is calling intermediate method. Intermediate method is right underneath it, which is calling inner method, and then inner method is right underneath that. So, hey, maybe still the space here is warranted if these are like two completely separate functions. They're doing two completely different behaviors. So, okay, yeah, maybe it makes sense to have the space here, but at least you're keeping them in close proximity to each other. You're not having intermediate method, at the very bottom here, and then inner method function call in between. So that's an example of that. Conceptual affinity. So certain code bits want to be near other code bits. Affinity means basically one function calling another, so two different code bits kind of going together. And there's an affinity because certain functions perform a similar operation. So there's affinity because one function calls another. That's one. And then two, there can also be affinity if just certain functions perform a similar operation. So the example used in the book is of this like assert equals class. Was it? Or yeah, like the assert class. And here's an example of that on the right. There's an affinity between all of these. You're asserting something, they're all void, they're all static, and they're used in normally testing, JUnit testing. You're asserting something is equal to something or not null or true. So there's an affinity here because they perform a similar function, not because they really call each other, but they're all performing a similar operation that you would use in other places in your code, like I said, mainly in like your unit testing files. So these are all going to go together. And when I mean go together, there's not going to be much vertical separation between these. They're going to be kind of close by each other. That's what conceptual affinity means. Now, maybe you could even get more in the weeds, and if you had like an assert not equals, assert false, assert null. Now maybe you could start separating it out a little bit to have the assert equals, the functions with the word equals in them. Maybe you can have these together, and then you have several line spaces, and you have the nulls and the not nulls together. And then you can have the trues and the falses together. And then, hey, maybe even those methods are overloaded. So what I mean by overloaded is that they have different sets of arguments and number of arguments. So maybe you can do that. So just keeping the affinities together, and maybe even that can break down even with more so detail. Like I said, the functions with null, they go together. The function with true, false, they go together and they're separate from the nulls, etc., etc. Hopefully that makes sense. And really, that example that I'm giving is very particular to this assertion helper screenshot that I have here. It's not just, functions aren't just because functions have similar names, true, false, like those go together, doesn't mean that they're going to perform the same operation. Could be performing very different operations, but just in the context of this assertion helper class, I think it would kind of make sense that you'd have like assert true, assert false kind of go together, assert not null, assert null go together, etc., etc. So keep it on with this vertical concept. We have vertical ordering. Function call dependencies should point downward, and the most important details should come first. Low-level details are towards the bottom of a file. That's what Robert Martin means by vertical ordering. So I think this verse bullet point is basically kind of similar to what we were talking about in the previous slide, just that, hey, the caller should be above the callee. So the function call dependencies should point downward. Whatever functions are calling other functions, they should be at the top of the file, and the functions that are being called should be below them. Again, with close affinity. And then most important details in the file should come first, with the lower level details towards the bottom. I feel like at work, I'm not sure if our files are structured exactly like this, but this kind of makes sense. If you want a coworker to get the main point of a source file, they're probably going to get the idea from reading the most important details and the most important functions. So it makes sense to include those first and not have somebody scroll through, especially if you have a lot of lines of code, scroll through all the way to bottom to get to the most important details of your file. So that makes sense. Horizontal formatting. So we went from talking a lot about vertical openness, vertical ordering, alignment. Now we're going to talk about horizontal formatting. So vertical and how long a file should be. Horizontal, how wide should a line be? How many characters should it be? And Uncle Bob says programmers, I guess no surprise, prefer shorter lines. And there's this thing that I never realized. It's called the Hollerith limit, where lines should only be 72 to 80 characters. But this is kind of an outdated term now, because the Hollerith limit was a concept that was used and derived from the physical limitations of punch cards. So where you would have to write the code on the punch card. And I don't think it was writing the code on the punch card, but it was making the punches in the cards to then feed into the machine. And then by reading where the holes are in conjunction to the other holes and the size of the paper, the machine could perform different functions. So the Hollerith limit was established at a time where you only had a certain amount of space on the card. Nowadays, in any IDE, you can just keep, pretty much going forever and ever, as wide as you can, as much code on one piece of line as you want, but there is a certain limit. And I know there are some IDEs and linting tools that will catch if your lines are too long. I know in WebStorm that I use for the React project we work on, it will sometimes show you an error if your line is too wide. And it's going to tell you, hey, take some of this and put it on the next line. Uncle Bob says, really? A line should be about 120 characters. Anything more than that is just careless. And this is kind of not a great rule, but he says, oh, you shouldn't be able to really scroll to the right. But that concept or that kind of rule is very up to interpretation, or just very dependent on your computer, because some people work with wide screens versus some people just work straight on their laptop, not as big of a screen. So it's going to be dependent on your screen size. Some people are going to have to scroll to the right. Other people with the big screen, they're not going to have to scroll to the right. But the hard and fast rule, hard and soft, fast rule, is you don't really want anything beyond 120 characters in a line. So now we talked about vertical openness and vertical density. Well, there's horizontal openness and density. So this is within a line. So when you have two distinct sides within a line, you want to separate them. So usually in assignment, when you're assigning variables, there's two distinct sides. There's the variable name, and then there's the value. And it looks much cleaner to have a space equals space in between, like that first bullet point, versus no space, like in the second bullet point. It helps to just, again, distinguish that these are two separate thoughts. You know how we talked about conceptual affinity and keeping lines of code together that go together? Well, it's kind of the same horizontally too. Keep the distinct thoughts on the same line separate. And that's usually the case for assignment. This is pretty much kind of, I feel like everybody does this automatically all the time. Just have this space, like the first bullet point. Now, you don't want to do this every time, though, because what about in your method signatures? Should you have spacing between the method name and then your arguments? Well, here Uncle Bob says that it makes sense not to have a space between the function name and the opening parentheses, because all of these are tightly linked together. Add numbers is utilizing two arguments here, num A and num B. So here it shouldn't have a space there. Another thing with operations, addition, subtraction, multiplication, the operations of higher precedence shouldn't have a space. So actually, I do have an example of this. So when you multiply in your code, there's no space here. It's just B asterisk B, no space. But addition and subtraction being lower precedence, PEMDAS, if you guys remember that from school, grade school, please excuse my dear Aunt Sally. Since those are lower on the spectrum, lower on the precedence, you're going to have a space between those. So A plus A space plus space A. But for multiplication, there's no space. It was interesting, though, in the example that he had in the book, he still had a space for the division, which I thought was interesting. But I guess it's not really division. It's like a ratio, I guess. But still, division is higher precedence. So yeah, that would be one question I have is, in the book, in the example, maybe I should have pasted an example here, but he had like B space slash space B for division. But for multiplication, it's together. So just remember that. Affinity it's the same concept vertically as horizontally. For assignments, you should have the spaces there. Method signatures, no space. They're tightly linked together. So just to think about that when you're writing code. Horizontal alignment. So this is where, if you can see on the right there, you line up all the variable names in a set of declarations. So private string name, and then you have private int age, private string occupation. Name, age, and occupation are all on the same line horizontally. If you can see that there, or vertically, however you want to put that. But you don't need to do this, says Uncle Bob. You don't need to do this because, and I kind of agree with him here, it takes away from the focus of the file. So when you do this, you tend to focus on the variable names and not their types. Obviously, in this case, this is a small file, very simple example. Okay, you probably wouldn't, gloss over that. But in large, very long files, this just takes time, takes away from a person focusing on the true details of the file. You don't need to go through it and line everything up like this. He says if you have long lists of instance variables that need to be defined, the problem isn't going to be the alignment. The problem is that you just have a lot of instance variables in this class, and maybe it would be better to just break it up into two different classes. Now, if all the instance variables go together, hey, that's your call, but it's just something to think about, he says. If the problem isn't the alignment, the problem is the length of your list of instance variables. Next up, almost done, guys, indentation. So we indent in proportion to the position in the hierarchy. Class declarations are not indented, but methods within the class are indented one level to the right. Implementation of those methods are one to the right. Code within the methods is one to the right, and so on and so forth. So you convey to your reader or your coworker the distinct thoughts. So again, conveying it vertically, the distinct thoughts, conveying it horizontally, and then I guess it goes horizontally too with indenting because you're indenting horizontally, but conveying it through indentation and what is within what and what has the hierarchy. My class up at the top is not indented. You can see that public is all the way to the left. One in of that, you have your instance variables and you have your constructor. Within your constructor, you have one more indentation to show that you are initializing your instance variables. And again, you have your methods, which are just indented one, but then within your methods, you have your functionality, which is indented even more, so that it makes it easier to read and easier to realize, okay, this code here is indented because it is within method one. So the functionality of method one is indented for better readability, basically. So you can better tell, this is what method one is doing. It's just a cleaner way to write your class files. And I think even most IDEs, sometimes like if you create a method and you hit enter, it'll automatically start the spacing for you indented. So it kind of does this stuff for you. But just think about it if everything was left indented here, how just kind of jumbled up and a little bit confusing this would look, because it would seem like, oh, everything has the same priority or precedence, when in reality, you want to have the distinction here between your instance variables. You want to have your distinction that, oh, this is a constructor and this is what we're doing inside of the constructor. So indentation is important for letting somebody know the hierarchy of your code. Now, there are times where maybe you would break indentation. So like here, this is the same, I think it's the same. Yeah, it's the same class as the previous slide. But in here, for the methods, they're all just on one line. So you see there, method one, system.out.print. This is all on one line, which sometimes we do this at work, especially if your functions are super, super small. But actually, Uncle Bob says he prefers to expand and indent the scopes instead. So even if functions are super, super small like this, and they're only one line of code, they're only doing one thing, like a print statement in this example, that you still want to break this up, have this on a separate line and indented. And I guess it's going to depend on your team, because I know I've been with some coworkers who think this is much cleaner. The file is a little bit shorter, and they just like that. Yeah, your file is just smaller. maybe you could even take out the spacing here between methods 1, 2, and 3. And then other people are going to, like Uncle Bob, are going to say, nope, have these on each separate line, have the indentation so that it tells the better story and it makes it a little bit more readable. You can understand what exactly each method is doing without having to like read from all the way to the left to all the way to the right. You can just read, top, bottom, top, bottom. Maybe it's a little more easier to read there. So yeah. Dummy scopes, and then I think this is, just one last slide left. Dummy scopes, this was something new to me. So a dummy scope is where you have a block of code within another block of code that is its own world. So you have a dummy scope within the scope of your function or your while loop or your file that performs something that is completely separated from the rest of your code. So here you have a while loop, and then within that while loop you have these curly braces. Within that you can see there it's labeled dummy scope. Good use of comment maybe, because I didn't know what a dummy scope was. And then you have this calculate temporary value, use their temporary value within the loop, but you're only going to be able to use it within this dummy scope. So make sure that the dummy body is indented and surrounded by braces. So this is what he means, indenting within the dummy scope so that they know that, okay, this is the dummy scope because this is indented more than out here. Like maybe out here the code would start at the curly brace, but within the curly brace it's starting indented one line more so that the reader is going to understand, okay, this is a dummy scope, this is doing something separate from this, etc. And then another point here, make a semicolon visible by indenting it on its own line. So, okay, so this means if I go back to the other slide, you see here how this semicolon is here? Basically, Uncle Bob is saying, okay, when you're doing this, sometimes it might be easier to have the semicolon on a separate line. So he says, I've been fooled by a semicolon silently sitting at the end of a while loop on the same line. Unless you make that semicolon visible by indenting it on its own line, it's just too hard to see. So sometimes it makes sense to maybe do this. So pretend like this is code like over here, or if I go back to the previous slide, this semicolon would come just on the next line. Just so people, and actually doesn't this need a semicolon here too? You would have a semicolon here, just so people understand that it's the end of the line. And I guess maybe they wouldn't have to keep scrolling to the right, or maybe they wouldn't think like, oh, this is a very long line, I got to keep scrolling to the right. Obviously, if you can't scroll to the right, you're not going to scroll to the right. But maybe it's just for better readability and just so you're not confused as to maybe when this line ends. Maybe. I don't know. To be honest, I've never seen this, to have this on a completely separate line like that. At least in Java, I've never seen this. So that was really interesting. The same train as far as, hey, what are you expecting formatting-wise? Your team should agree on a single formatting style, and everyone should follow it. Because, again, the formatting is going to continue on for the... You could see how things could get confusing. And like I said in that last slide, or that last bullet point, early Monday morning, it's going to be dropping with Adam Fitzgerald. Check that one out. Great interview, my longest interview that I've done.